Hello, and today I'm going to be going over the October-November 2018 paper. This is paper 1, and this is version 2 of paper 1. So this first question is asking us about ASCII, which is the American Standard Character Information Interchange, and ASCII represents the American English alphabet. That includes all the letters and all the different characters and symbols. So we're asked to represent these as denary values, and again, you're never asked to learn the ASCII table. They will always give you the extracts of what you need. So a capital B is the denary value 66, and it's asking you to convert the denary value, the base 10 value 66, into 8-bit binary, so into base 2, 8 bits. So the answer to this, using the binary grid, would be 64 plus 2, and because it's requiring 8 bits, you're going to have to write in the 0 here. So it's 0, 1, 0, 0, 0, 0, 1, 0. Now the same process needs to happen for 85. Obviously we're going to use this grid, and 85 would be 64 plus 16 plus 4 plus 1. And again, very similar for 83, 64 plus 16 plus 2 plus 1. So for these kind of questions, it's easier to either draw this binary grid on the exam paper somewhere, or ask for some a separate sheet of paper where you can draw the grid and do the working out. Now we're talking about hexadecimal values. So here they've given you the letter in the ASCII alphabet, and they've given you the binary version. You're going to have to convert this binary into hexadecimal. So just a reminder that hexadecimal runs from 0 to 9, and then 10 to 15, and the 10 to 15 are represented as A, B, C, D, E, F. So this goes from 0 to 15, which is 16 states, which is why hexadecimal is base 16. So what we have to do to convert this binary into hexadecimal is treat it as 2 nibbles, so 4 bits. So 1, 2, 3, 4, and then you would split it, and 1, 2, 3, 4. How I've done this is shown here. So I've taken this section here, so 1, 1, 0, 1, and that becomes 1, 2, 4, 8. So 8 plus 2 plus 1 is 11, and 11 is represented as a B. And then here we have 0, 0, 1, 0, that is a 4, so this is 4B. The same thing needs to be done for this next question. We're going to split it in half, and this time it's 0, 1, 0, 1, and this is 5, 4 plus 1, and then we have a 4 here. So this is 4 and 5, not 45. It's 4 and 5. And the last question here is, this last one here is 1, 0, 0, 1, which is 8 plus 1, which is 9, and then again we have 0, 1, 0, 1, same as we had here, which is a 5. So this is a 5 and 9. Okay, now it's asking us to explain the uses of hexadecimal in computer science. So hexadecimal is used in a few different places. So it's used to represent HTML color codes, where you would have maybe FF0372, which would represent maybe a shade of blue or a shade of green. Error messages, so we spoke about these in class. Memory dumps are usually represented as hexadecimal because they're easier and quicker to read. MAC addresses use hexadecimal. IP addresses, so IP addresses version 6 uses hexadecimal, version 4 uses denary values. Assembly language uses hexadecimal as the reference points for where data is stored in the main memory. And again, memory dumps, I spoke about error messages and memory dumps here. Again, error messages can be, one of the most famous ones is the error 404 message that you see when a website can't be found. That is, the 404 is actually representing something in hexadecimal. And again, as I said, mentioned with assembly language, they're used to represent locations in memory. So what are the benefits of hexadecimal? It's easier to read, write, and understand for humans than binary. It's easier to remember than long binary numbers. It's a short way to represent binary, so it uses less screen time. So if you had an error message or a memory dump, You can fit a lot more on the screen if you use hexadecimal. If you are writing assembly language and using hexadecimal, you're making fewer errors because you're not writing singular zeros and ones. You're writing the abridged kind of hexadecimal character set. And it's easier to debug. Again, if it's easier to read and write, it's easier to debug because you can spot errors. Now moving on to RAM and ROM. So we went over this way at the beginning of year 10. So stores the programs and data that are currently in use. So that would be the RAM. The RAM stores all applications and data that's currently being processed. Remember, the RAM is volatile, so it processes everything that's holds everything that's currently being run. But if the power was to go, that would all be lost. So the ROM used to boot up the computer when the power is turned on. Yeah, remember the ROM deals with the BIOS, which is the basic input-output system. So checking that your computer has the right components to function. And then if it has all the correct components, then the computer will boot up. And again, as I mentioned with the RAM loses its power, loses its data when there's no power. The ROM keeps its data when there is no power. It always keeps the BIOS and the boot up instructions. So now we need to think about the category which includes RAM and ROM. Is it primary storage, secondary storage, or offline storage? RAM and ROM are primary storage. The computer will not function without the RAM and ROM. Therefore, it's primary memory or primary storage. What is meant by offline storage? So it's non-volatile. It's storage that can be disconnected or removed for the computer. An example would be a flash drive, a USB flash drive, or a CD or a DVD. Again, you must physically connect the computer, so I must physically put a CD or a DVD into my DVD player or CD player for it to run. I must physically insert the USB flash drive into the computer for it to work. And you could say that we could use them to store files as backup. So usually you would store, CDs are very cheap, so we could store lots of information on there. We could have an external magnetic hard drive, which could be used for file storage. And again, out of these, you would pick two. I would mainly say that the first two are kind of the simplest ones to remember. That it's non-volatile and it's storage that can be disconnected. And again, if it's disconnected, it can operate without any power. Now we're going to go to a logic gate question. Again, a few people in class time have been confused by these when they turn these logic gates into these word problems. So here you've been given the binary values for W, T, and H, and these different commands, so if the window is open or closed, for example. So we need to turn this into a circuit. We can see that there's going to be an OR at the end. So an OR will be over here. But what we need to do is look at the window is closed and temperature. Okay, so window is closed gives me 0. So window is closed, 0. And temperature is greater than or equal to 26. So that's a 1. So I can automatically see I can't have an AND that functions with a 0 and a 1. For an AND circuit to function, both have to be true. Both have to be 1. So what I need to do here, as I'm already seeing that I need to include a NOT gate to convert this 0 into a 1. So essentially it becomes 1 and 1, which means this first part of the logic circuit can become activated. The same thing is going to happen here. So temperature is less than 26 is 0, and this is a 1. So here temperature, which is T, I'm going to have a NOT because I need to make both of these 1 for an AND circuit to work. So I'm going to have to put a NOT here. Again, as I've done in the other exams, I can't draw these out in PowerPoint, so what I've done is included the logically circuit. So you can see that W here, this is a 0 coming in, that becomes a 1. So then both of this can become activated. So a 1 and a 1 would produce a 1 here. Same for this bottom half of the circuit. I need to make the T, this 0, into a 1. So the NOT goes through. If this was a 1 as well, both of these lines would be blue. So that would produce 1, 1, and then this would activate. Again, this OR means if this thing happened or this thing happened, T, which in this case I've done as a light bulb and logically, but it'd be whatever system would be set up to make these plants grow in the greenhouse. Now we need to identify some security risks that can put your computer at risk. It says only 3 here, but there's quite a few that we need to consider. So malware and viruses. And again, if you've got no antivirus, that's a problem. Denial of service, spyware, or having no anti-spyware installed can be an issue. Any form of phishing, so people trying to get your personal information through email scams. Farming, which means that you think you're going to one website, but the DNS, the domain name service, has been hacked and it's directing you to a completely different website that could be contain dangerous materials or might contain viruses that you could download, or look like a legitimate website and you could think you're using the real website and using a fake version and put in your credit card details. Again, security issues such as hacking or cracking. So hacking would be using a kind of refined approach or programming approach to hack into a system. Cracking would be that you keep trying different combinations of things and something works. So hacking would be me trying to, like, maybe if we think about a door, hacking would be picking the lock of the door. Cracking would be kicking at the door until it eventually broke. Having no password or a weak password, having no firewall or a weak firewall, using or downloading unknown software from unknown sources, usually torrenting something that says it's cracked or says it's a pirate copy, but you don't know what other people have added to the software. Not keeping software up to date. Again, operating systems, if they aren't kept up to date, can be left open to exploitation. Backdoors can be found into systems that aren't using up-to-date security protocols. And again, you could always mention physical issues, so not locking a door, not having bars on the window, not having security cameras in a room with expensive equipment, things like that. So now we need to explain how a firewall functions. So a firewall examines, or you could say monitors or filters traffic that comes in and out of a computer. You set up criteria, what things you are going to allow in and out of the computer system. Essentially, when something's arriving or something's preparing to leave your computer, it checks it against these criteria or rules. Anything that does not meet these rules is blocked. It could also warn you of any unauthorized software trying to gain access or anything unauthorized being sent out of your computer. And again, this is very important that it keeps a log of the traffic, so you can check your firewall to see what things have tried to get in or tried to get out that haven't met these criteria. Okay, now Karina is taking an exam and she's got 3 questions about output devices. So it's asking here, it's a high-powered laser that cuts materials such as thin metals or wood. So we have a clue in here, it cuts materials. So this would be, an acceptable answer would either be a 2D cutter or a 3D cutter. So a 2D cutter would be a pattern made on a computer, and a laser would cut it out of 2D materials. And again, a 3D cutter would do that, but out of a, say, a block of wood or a block of stone or a block of solid material. The laser would then cut away everything that wasn't needed to produce something in 3D. Now she needs to think of a screen as made of blocks of red, green and blue pixels. The screen uses layers of different types of liquid. Again, the clue is in the title here, liquid. We know there's a few different types of screen, but a liquid, when it uses liquid, it's a liquid crystal display or an LCD screen. This last question here, it is responsible for powering and moving a motor in machinery, such as a robot arm in a factory. So when we're talking about anything that moves something in computer science or makes a real world action or movement happen, they are called actuators. I like to think of them, or a way of remembering, is that they make something actually happen. So you would usually have a sensor, and that would go through a processor, and that would be connected to an actuator, something that would happen in the real world. This is quite a relatively easy question. I like these questions because you have all the possible answers, and usually if you read the sentences, you have some context, and you can make an educated guess if you don't know or if you haven't revised it off. So and something allows you to write on a surface using a pen. The text and drawings can be captured and stored for later use. So that's what we have in school. So an interactive whiteboard. A something type of printer produces a hard copy of a document using something and piezoelectric technology. So this one might confuse people a little bit. So let's go through this now. So an inkjet printer produces a hard copy. It uses thermal bubble technology, so heated bubbles of different colors of ink. And this electric technology is what heats it up and then also seals it off. A laser printer uses rotating drum and positive and negative charges to produce a hard copy of the document. So here, if you were stuck on these ones here, like inkjet thermal, and this term here, you could see the next sentence, it mentioned drums, and we know that only a laser printer has drums, so you could make an educated guess about what the order of these words was going to be. This next section talks us about high-level languages and different types of translator, and we know that the two types of translator that can be used for high-level languages are a compiler, which reads the entire file, checks for errors, produces an error report at the end, and also produces an executable file. An interpreter is used for testing in an integrated development environment like Python's IDE, and it reads code line by line and stops if there's any errors. Because it mentions high-level languages, we can't mention an assembler, because an assembler only converts low-level language to binary. So it will convert low-level assembly language into low-level machine code, which is binary. Now it's asking us for two reasons why we would write something in high-level language rather than something like assembly language or binary. So these are the few, I'm going to give you three of the most straightforward answers you can put here. Again, high-level languages are closer to English, and you have to give a reason. That makes it easier and quicker to read, write, and understand. It's quicker to debug and therefore less likely to make errors. Again, high-level languages can be used on many different platforms. You can't run Python just on one type of PC. You can run it on many different types of computer, many different makes, many different versions of operating systems. We can write them in source code, and because it's compiled into object code, it's easier for us because we can write source code, which is our Python files, and the interpreter will turn it into the object code or machine code for us. We don't have to sit there and type our Python file and then type it out again in binary for the computer to understand. And again, you only need to learn a single language, as Python can be used on many different types of computer. Same for if you learn Visual Basic or C++, or many of the other different languages, they can be used on many different types of computer. So now it's going to show you some examples. Again, this is a relatively straightforward question. So this obviously is showing us some binary, and that is machine code. This is showing us some kind of pseudocode, but it looks very close to Python that we've been learning. So high-level language and some assembly language, as we've been learning for the little man computer. We've got IMP, STA, and ALDA, which is using mnemonics, which is assembly language. Now we have some questions about the internet. So we need to figure out what a browser is. So a browser is something like Google Chrome or Microsoft Edge. So a browser allows us to view web pages. So an internet service provider, the clue's in the name, it's someone that you pay money to provide you the internet. So Digi, for example, or Vodafone or Orange. So it's a company that provides a connection to access the internet. HTTP is the main protocol that governs the transmission of data. If it said HTTPS, it's pretty much the same, but it governs the transmission of secure or encrypted data. A uniform resource locator is the web address that is typed into the address bar. So www.cambridgeschool.ro, www.bbcnews.co.uk. That's the URL. The MAC address is a unique address given to a device on a network. It is provided by the manufacturer, and a MAC address is split into two halves. First half, the name of the manufacturer, a code for the manufacturer. So Dell, HP will have their own MAC address code, and the second half of the MAC address is the actual serial number for that device itself. And an IP address is an address given to each device on a network, and it's provided by the network. So a MAC address is given by the manufacturer. So in your phone, there'll be Samsung or kind of an Apple part of the MAC address, and then saying which device number it is. And if I wanted to join my home network by connecting to a router, my router would give me an IP address on that network. And again, a MAC address is fixed, but an IP address can change depending on what network you're on. So now we need to describe the purpose of an interrupt in a computer system. So this links to the operating system. So an interrupt is very similar to an interrupt in real life. If I was doing something and I was interrupted, I would have to stop what I was doing, go work on something else for a little while, and then come back. So the processes of interrupts are, they're mainly there to make sure vital tasks are dealt with straight away. Usually an interrupt signal tells the CPU that attention is required. It's either sent from a device, so like a keyboard, a mouse, a printer, or it's sent from software that something needs to be done. The interrupt will cause the operating system to pause any processes, and then it will get the operating system, the CPU, will then, sometimes it's called service, sometimes it's called handle the interrupt. It's important to remember that different interrupts have different levels of priority. There's very urgent interrupts, and there's ones that could wait a little while to be dealt with. And usually, or always, after the interrupt is serviced or handled, the previous process is continued. So again, this seems like a lot of steps, but your computer is doing so many billion things per second, so it can usually switch between tasks quite seamlessly. And as this last point saying, this is what allows you to multitask. So at the moment, I've got my screen recording software and PowerPoint running. So the computer is constantly switching between the two to do everything they need to have happen to function. So when I'm pressing something on my PowerPoint to make an animation happen, an interrupt has to happen to make that animation run, while simultaneously keeping the screen recording software. And again, they're not happening simultaneously. There's a small microscopic gap between the two, a millisecond gap, but it looks seamless. So computers can transmit data using different methods. So there's serial, parallel, and duplex. Remember that serial is where it's one bit at a time and down a single wire. And the bits arrive in the order. So you're sending them one at a time, so they arrive 0, 1, 0, 1. With parallel, it's multiple bits at the same time, being through multiple wires or multiple channels if it's going wirelessly. And the bits might arrive out of sequence, which means they've been skewed. And if they're not reordered on delivery, you can get the information or data can get corrupted or appear wrong. Like the binary code for an A could suddenly become a H if it doesn't arrive in the correct order. So your Word document would have misspelt words or wrong information in there. And duplex data means that data is transmitted in both directions at the same time. Just remember, people often get confused because in the books it says full duplex. So remember, there's half duplex, which means it goes both directions, but only one at a time. If it just says duplex, you can infer that means full duplex. Now we're going to continue to looking at if data was being transmitted, how we could detect the errors. So one way is a parity check. and we've been through this in class, so you need to say a couple of points of how it works. So you decide which parity you're going to use. You count the number of ones to see if they are an odd or even number. You add a parity bit to make, if you want them all to be odd, you add either a 0 or a 1 as a parity bit to make them all odd, for example. And when you receive it, you check to see if they all meet the rules of the parity, if they're all odd or even, depending on how you've set it up. And if anything doesn't follow those rules, it's detected. A checksum means that you perform a calculation of the data to get a certain value. You send the data and the checksum. I would then receive the data, receive the checksum. I would do the maths again on the data and to produce my own checksum. If they matched, that means it's arrived correctly. If my checksum didn't match the one I received from you, that means something's happened during transmission. And the last one is an automatic repeat request. So data's been sent to you, and if it doesn't reach you in a certain time, there's a timeout signal sent. So you send me data, and it requires an acknowledgement signal for you. If that acknowledgement doesn't come, then the data is sent again, because that means that package of data or that packet of data has gone missing. When data is received that contains an error, you will check, you don't send the acknowledgement, and you will automatically get it resent to you again. Now, the last question in this exam is asking us about sensors and detection and how this works. So the sensor would send data to the microprocessor. Again, it's always worthwhile mentioning here that it's converted into a digital signal. So this pH sensor measures the pH as a number, and that gets converted into a binary signal. It then compares that binary signal to the stored ranges of 6 to 8, for example here, this range check. So if the reading is greater than 8 or less than 6, it's outside the range, and the microprocessor will send a signal to output an alert, say something's gone wrong with the pH. And the last thing you should always mention on these questions is that this is a continuous process, that if it's a monitoring system means that it's always continuous, and no matter what happens in this system, the pH sensor will always continue to work in the same way. A control system means that maybe if the pH sensor was taking measurements every 10 minutes and it spotted an error, if it suddenly switched to taking them every 1 minute, so there was a change in the way that inputs were collected, that would be a control system. That's the key difference between a monitoring system and a control system.